Hi, I'm Mark Clayton, CEO and founder of SMARTreview Incorporated. SMARTreview has created a new way to conduct an architectural design review for compliance with the building code. You can work inside Autodesk Revit to make a 3D model of your building design, and when you need information about a particular condition and how it is affected by the building code, you can simply run an automated plan review. The answers about compliance or non-compliance appear as annotations of the building code, as a list of building elements, or as annotations on your Revit model. Now that you have the information in the context of your design, you can make the decision quickly about how to achieve compliance. Here is a simple building in Revit. To perform any sort of plan review, the BIM must have some basic elements to make a complete building. This BIM has floors, walls, roofs, doors, and windows. The building code is also concerned with rooms, areas, levels, and a property line. With these basic elements, APR can analyze the design and provide feedback on compliance with the building code. Before I run an analysis with APR on this little insurance office, I'm going to set my view to be a 3D transparent view. You don't have to do this, but this view is great for seeing the results of the code analysis. The APR command is issued from the add-in menu. APR starts extracting information from Revit. It mostly pulls parameter values, but it also does some small calculations. It's pretty quick. In order to perform the analysis, we need to add values to a few more parameters. I must configure the model first to provide these various parameter values and settings. Configuration is pretty straightforward. To demonstrate how it works, I can just walk through the various categories of settings. At the top, we have site settings. I can look at the frontage of the building, so this is whether there is a public way or open face facing one exterior wall or one or more exterior walls of the building. I can change that very easily. I'm going to add some frontage to the west wall, like that, and hit apply. And you see the area factor increase due to frontage changed up to 25%. In fire separation, this is simply the distance of those exterior walls to the property line. And I can calculate, it's already calculated, so that's fine. I could override it, but I'm not going to do that. The building concept is basically the idea that this is a B occupancy building. I can pick any of the occupancies listed in the building code. I can set the construction type, so a type 5B is a good one to go for on this. And let's try doing it with no sprinklers, and we're using IBC version 2015. I can also set which levels are used to determine the height of the building. So a grade plane, a first story, and a highest roof. With stories, the software has figured out what the stories are, but I have to tell the software which ones are levels of exit discharge. In this case, it's a one-story building. The first story is the level of exit discharge. I'm going to skip over the areas and the rooms. They're a little bit more detailed and they're mostly informational. In construction, we can set some of the values that are associated with the constructions. So for wall types, we could set a fire rating. I generally don't set these in this place because they're type parameters in Revit, and I have them set in Revit already. So this is just pulling the value from Revit and displaying it. You can override it, but that's probably not a good practice. Exterior wall instances allow me to determine whether a wall faces a street or something else. So I could make that west wall be facing open space, unoccupied space, such as a parking lot. The floor types, again, this is a fire rating value, and I can set that, but it's a type value. The roof types are another type value. It includes also the flame spread classification. Door types, fire ratings. Window types have a fire rating, and window instances I can set them to be protected openings or leave them as unprotected openings. The egress settings are a little bit more complicated because they depend on occupant loads and the paths. APR allows me to fill in the occupant loads based on the function of space as defined in the building code. Now, just to show you how to do this, I'm going to select all of these. Right now they're set as a daycare, but this is actually a business use, so I'll scroll up here to business area and pick that and apply, and it recalculates the occupant loads based on the occupant load factor for businesses. I could override those. I'm not going to talk about that anymore today, but in a future post maybe I'll go through overriding the occupant loads. Doorways are another major issue. The APR figures out which doors are exit discharge doorways, and it also classifies doors as egress doors. I can pick a door and make it and exclude it from the calculations, and sometimes I want to do this, such as an overhead garage door, which is not supposed to be used for egress. Once I've got the doors set, I can calculate the paths. So I'm going to run this, and it does the calculations and displays it for me. So I've got both the exit access travel distance for the room and the common path travel distance for the room. In this case, there's only one exit, so the common path travel distance equals the exit access travel distance. There are no stairways, so we're not going to go over stairways in this presentation. But at that point, we've configured the model. Once the parameters are given appropriate values, I can initiate an analysis from the analysis menu. We wait a few seconds to check hundreds of items and situations against the building code. First, it's packaging the information from Revit and then sending it to the cloud analysis service. The results pop up in the analysis service. You can look at the results in three different ways, and to show you those three ways, I'm going to collapse this hierarchy, and you can see that there's the IVC hierarchy, which presents the information in terms of the building code, and then there's the architecture hierarchy, which presents the information in terms of the various parts of the building. Now, a little bit more subtle, you may not have noticed as it went by, but as the software calculated, the Revit model itself changed color over here to highlight the parts of the building that are in violation. So I can see this wall and this door are in violation of the code. Let's look at the architecture hierarchy first. This may be closer to the way a designer or the designer's client thinks about the building. I can expand out the hierarchy and see the elements that are in violation. So I can look and see that this is the wall that's in violation, and we can look at the doors and find that there's a door in violation. I'm going to zoom in on this so you can see it better. I'm just pressing Control plus to zoom in, and I'm going to pull this over a little bit. I don't need quite as much space in this left panel, so we can see it better. And then I can scroll down here and we can see the wall that failed. And it describes the problem. The door wall in print is 30 inches wide, which results in a minimum clear width of 26 inches. Basically, the door needs to be wider, so we can make that change. Another way to look at the results is to browse the building code hierarchy. So I'll close the architecture hierarchy and open up the IVC hierarchy. I can expand and collapse sections of the code to navigate through it. Now, since there's no problems in Chapter 5, building heights and areas, I'm going to close that down. There's no problems in Chapter 6, types of construction, so I'll close that one. There is a problem in Chapter 7, fire and smoke protection, and I can come down here and see the problem is sections 705.8.1, allowable areas of openings. Now, if I scroll down, I can see the excerpt from the building code itself right here. And then I can also see an analysis of the building from the point of view of that section. So they're presented as a table. I can see that the east wall failed. The wall has an estimated area of 343 square feet and is 2.88 feet from the property line. And it has unprotected, non-sprinklered opening area of 112 feet. But unprotected, non-sprinklered openings are not permitted at all for the wall. So that's a problem. It's too close to the property line. APR works well in an iterative process of design. Try something, see the consequences, adjust it, see the new consequences, repeat. So I'm going to switch back to Revit to make some changes. I'll just close the APR here, and I'm back in Revit. And first I'm going to change this door over here. It's a very simple fix. So I'll click on the door and I'll change it from a 30-inch wide door to a interior single flush 36-inch wide door. And you'll see it change in Revit. Now the problem with the windows over here, it says I cannot have windows that close to the property line. So I'm going to change the location of the property line. That's sort of like moving the building. I should really move the building, but it's a whole lot easier to change the location of the property line. So for illustration purposes, that's what I'm going to do. I'll come over here to my plat drawing, and I will unpin the property line, and then I'll click on the property line and drag it away from the building a little bit. I could be much more precise, but let's do it this way. And so that's a change, and we'll see if that's going to work. So I'm going to run the APR again, and we'll find out if that works. Here it goes. It's extracting the new data and sending it to the server, and it puts it up on the screen. So here the APR has come up again, and I'm going to go straight to analysis and run the analysis with our new BIM. Takes a few seconds to extract the data and send it to the server. Chapter 5, of course, is still fine, and Chapter 7 now passes, so the building works. These allowable areas, we can take a look at that, see what it says about it. And we see that east wall has 112 square feet and unlimited openings are allowed when we're 12 feet away from the property line. So it looks like the building all passes now, and we've reached a compliant building. So this door down here that was a problem before, size of doors, is no longer a problem because we made it 36 inches wide. This is a simple building, and APR can handle more complex buildings. Just to kind of show that, I'm going to bring up a small hotel here. And so this is a 4-story hotel. It's a demo building. It's not a real building. But it's a 4-story hotel. It's got 2 stair towers, a lobby, over 100 or 150 guest rooms. So the path calculations, of course, are much more complicated. The size of the building is more complicated. The relationship to the ground is more complicated. It's got a penthouse. So this becomes a more realistic example. But I would suggest that if you're interested in learning more about APR, that just go ahead and download the software and install it and try it out on a simple building such as the little insurance office. You can download that building too if you want to from our site and give it a try. So thank you for watching this video. I hope to meet you in person in the future.